Hey everybody, this is Larry. This is is it the last day? Yes, May 31st of the May Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem. So given a binary string S and an integer K, return true if every binary code of length K is a substring of S. Otherwise, return false. Okay, so I mean this seems pretty brute forceable, I suppose. This is also something called, I believe, it's been a while. So just gray code, maybe gray code, but it's been a while. Don't remember the name of all these things. Though, yeah. So I think this is yeah, I think the pattern that we've seen the last couple of days is this idea of using bits and stuff like that. Yeah. What else was? I don't know if there's anything to say. We just have to basically. Yeah, we just have to. I'm just trying. Sorry, I got distracted a little bit to see whether if K is like it's still like I think there's a pigeonhole type thing, but for now we can just have a set and then just do it. You can. I was also debating whether it's easier to like create an array versus a set, but I don't think it matters that much. But I was just thinking about it in either case. But yeah, but I think this is just a standard brute force kind of thing. But you have to be a little bit clever, not a little bit clever, yeah, just a little bit more clever than the brute force, and that should be okay. And the idea is that, given that n goes to 5 times 10 to the 5th, or what is that, like half a mil? Or 5, is that 5 mil or half a mil? No, it's half a mil, right? So half a million, and if you do half a million times 20, it's still probably gonna be good as 10 million, but if you do it slightly faster, it should be even better, right? Because if you I think brute force will work if you just take like everything and then hash it. The thing that you can get into trouble a little bit is also like if you have 10 million, if you hash the string itself, it may use a lot of memory. I don't know if you'll run into like memory limited exceeded or something like that, but it's still a lot of memory and it's still something of concern. So the way that we're going to do is just taking advantage of the fact that it is a binary number, and then just convert to binary. And also that, yeah, let me just take this real quick. And take advantage of basically a sort of sliding window, right? And sliding window is an idea that you should really be accustomed to if you're doing interviews and stuff like that, because there's some sort of idea around greedy. But the idea here is that, let's say we look at 3 characters, right? So let's say we look at these 3 in the middle, and then now to go to the one to the right, well, we can reuse most of the work from going from 110 to 101. We can reuse most of the work, and having the ability to reuse that work will basically, just it's good for your health, and good for your time optimization. But yeah, so that's pretty much the idea. So let's get started. So length, I just like to type it out, but yeah, for I in range of n, and the way that I'm going to do it is basically kind of sliding window, but maybe I call it a sliding window, but it's still the same idea of just shift and add. So then now there are a couple of things we can do, right? First is that we just keep track of the current. So then now we look at S sub I, of course. So we have to shift. So yeah, you can write it like this. You can write it like this. It's the same idea. You just shift everything to left 1. And then now to keep the last K, you want to mod it by 2 to the K, right? So you want to do something like this. There are different ways to do it. That's one way to do it. Mod is a little bit expensive if you want to think about it that way. It doesn't really matter. I think especially if you're a beginner, just try to get it right. But the way that I would write it is just something like this. And then now we can do something like this. The reason what this is just that, just say, it's just saying, give me K1s, right? And then give me K1s in a row. That's what basically what this does. And then the end will basically just say, okay, now we only care about the last 6 ones or 6 digits and so forth. And that's basically what this is doing. And then now you can write this in a couple of ways, but let's just say we can do this and then right? Maybe something like that. And then now, and also keeping in mind that the order of these two things don't really matter because you just get rid of it and then or it anyway. But then now we take advantage of the scene, and then we just go and add scene. And at the very end, if it contains all the binary codes of length k, it has to be the length of scene has to be equal to what is it? 2 to the k, right? Is it 2 to the k or 2 to the k minus 1? No, it's 2 to the k. So yeah, so then we can just do the same thing. And this should be good, I hope. Whoops. Wow, I am like, I don't know what that was, but just typo, but very weird, silly one. Cool. So yeah, so this is no good, no bueno. Maybe I misunderstood this one. Yeah. I actually did think about this, but I forgot it about. I forgot to do it after, because I think I was just explaining this part and I forgot about it. This is one thing that happens when you're explaining, or for me, when I'm explaining code live, is because I was like, okay, I have to do this thing, but then I also want to talk about some other things that I forget. But yeah, but basically you have to make sure that this is of length. I'm gonna think. Right, I think this is actually k plus 1, and then yeah, that should be good. Because basically what happens to, oh, I messed up. Is it k plus 1? Let's see, if k is 2, then 0, and after 1 it should be good, right? So why is this? I think it was more right before, but now I'm a little confused. I think this is more precise. The reason is because basically we needed this at least because what was happening on the last case was that it was adding 0, even though yeah, it doesn't really, yeah, because it was adding 0 before it used 2 characters. Now, still wrong for some reason. Even though it should be pretty straightforward, so I'm a little bit sad. Let's see. Maybe I just have another typo. Why did I write k plus 1? It's k minus 1. Duh. Because we were just saying that, like, or in my head I was like, the easiest way to figure it out for me anyway is that if k is 2, what should I be the last one? And I is obviously should be 1. So that's how I did that way. But then I don't know. I took a nap earlier and I'm just getting confused. But yeah, it should obviously be k minus 1 and not k plus 1. Yeah, just silly typos today. Anyway, let's give it a submit. See how that goes. Cool. May batch, nice. What was 791 days? A little bit slower than before, huh? Maybe I used a. I probably could have used an array here. Maybe that's a little bit faster. You can experiment with whichever is better. But and you can also early terminate, I think, by the pigeonhole principle, by just the length of the string. Those are kind of 2 things you can do. But otherwise, this is linear in the size of the string, depending on how you want to think about bit mask operations, right? Or bit rise operations, sorry. But yeah, that's pretty much all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye-bye.